few months ago, this vehicle was brought into a shop with a complaint of pedal pulsation during braking. The technician diagnosed the vehicle as warped rotors and replaced the rotors. Within a short period of time after that replacement, the vehicle came back again with a complaint of pedal pulsation. Today, what we are going to do is let's dispel the myth of warped rotors and show you the diagnosis procedure to help eliminate pedal pulsation. Many technicians will diagnose pedal pulsation as warped rotors. Let's dispel that myth right now. Rotors do not warp. To warp a rotor, you physically have to change the metallurgy of that rotor. To change the metallurgy of the rotor, you're running in excess of 2,300 degrees. There is no brake system that runs 2,300 degrees. Let's take this apart and see what the issues are that causes the thickness variation. Typically, every time a vehicle comes into a shop with a complaint of pedal pulsation, the technician looks at it as warped rotors. As I mentioned before, rotors don't warp, but what causes the pedal pulsation is disc thickness variation. Disc thickness variation is caused by excessive lateral runout. Let's take a look at this rotor and see if we can identify some areas that have caused this condition. When we look at the rotor, you can see some black marks in the rotor. Typically what that is friction transfer from ceramic brake pads. Ceramic brake pads lay down a coating of friction material. That has been laid down unevenly, which ends up being thickness variation, causing pedal pulsation. When we turn the rotor around, the other area you want to look at is the mounting area. We can see a big rust buildup on this area here. When this rotor was installed, that hub wasn't cleaned properly. Let's take a look at the hub. As you can see on this hub, there is a lot of rust buildup on here. This rust can cause excessive lateral runout, which induces thickness variation. Let's get this cleaned up. We got this hub all cleaned up. Our next step is to install the rotor. In many cases, there's a couple different options you can do. We can either replace the rotor or remachine the original rotor. This particular application, we're going to replace that rotor. Once we've installed that rotor, it's very important. The next step would be to check lateral runout. Typically, lateral runout in a vehicle like this is 2 thousandths or less. Let's check this lateral runout and make sure we're within specs. Okay, we've installed the rotor. You have to make sure that you install all lug nuts and torque them to specifications. Mounted the dial indicator, and as we spin this rotor, looking for the specification, which is 2 thousandths less, we're right at 1.5 thousandths.